he actually references, oh, thank you. He references passive house as one of the pathways to reduce our global greenhouse emissions by 80% by 2050. So that was kind of a big boost. Thank you very much for this opportunity to talk with you. What I'm going to talk about is passive house, the concepts that are related to passive house initially, and then a couple of projects that we're working on briefly, but then get into the discussion about what's happening with New York City now, and also at a federal level with respect to passive house related legislation. Passive house is it's an energy conservation strategy. If you think about the discussion that you may have heard about this idea of the fifth fuel, or the least expensive energy source, it's the energy that's not used. And passive house, I mean, there are, I'm going to say, some of you were probably alive in the 70s, right? Okay, so alive in the 70s. So in the 70s, we were doing a lot of activities that were really good and smart with respect to energy conservation in this country. Jimmy Carter put solar panels on the White House. I remember putting, yeah, they were on there. Mm-hmm. He had a tax credit for solar panels that promulgated a lot of active hot water systems in the 70s. I was working in Virginia doing projects that got grants for those solar hot water heaters. I went to California looking at sustainable communities, and there were lots of things that were smart that were happening in the 70s. 1980, Reagan gets elected, and it's like we took a right turn as a nation away from that. But what happened was during the 80s, there was a German physicist named Wolfgang Feist, and he was looking at energy conservation and actually looking at what we were doing in North America in the 70s. And there was some great work occurring in Canada and also in North America, where we were doing super insulated buildings, using better windows, looking at the idea of heat recovery, ventilation, and tighter air barriers and the such. So we were doing that, but we didn't really have a system of kind of doing it intelligently developed. So it happened kind of piecemeal. So he looked at it systematically as a scientist would, and he developed this passive house protocol for how, he says, listen, we're concerned about energy use in Germany. They don't have the same fossil fuel capacity we have and such, so they were looking at how they save energy. He said, well, the first thing and smartest thing to do is simply reduce the amount of energy that you need first. Like, reduce it as far as reasonably possible. Then you just need to use less energy for your building. So this led to the development of some principles regarding passive house. Now we'll say this was 1990. There was they built a building in Darmstadt, Germany in 1990, still there, and since then there have been probably 40,000 buildings globally that are built to the passive house standard or near passive house. And there's a lot of science behind it that they are, in fact, working. So basic principles, you wrap the building in a blanket of insulation. Like, it's continuous insulation. The thickness of the insulation is based on what climate zone you're in, but you want continuous insulation. You want a very tight air barrier so that the houses are very like super tight, and the standard is 0.6 air changes per hour at 50 Pascal. That's a measurement for a blower door test. Excellent windows, triple glazed, no thermal bridging. They usually have a U value of 0.15 is the passive house window standard. Thermal bridge free for the structure itself. Now this concept, it's kind of like if you think about buildings in the city where they've got the concrete balconies that kind of cantilever out from those. Those are enormous thermal bridges. Like, you could have insulation, like thick insulation all around that building, but that concrete balcony the energy is pouring out of that concrete balcony. That's a thermal bridge. So you can have thermal bridges in windows, you can have them through structure, through columns, through roof overhangs and such. So you've got to think about and design a building that's thermal bridge free. And then heat recovery ventilation. The idea you build this tight house, but then you ventilate that structure continually. But in the process of that ventilation, where you're bringing fresh air in, but you're also exhausting air out through the structure, you've got to have a crossing or an exchange where the energy that's embedded in the air that's in your building, it gets transferred to the air coming in, so that in the winter you're not bringing in 0-degree air, you're exhausting 70-degree air, but you're bringing in air which can grab heat from that 70-degree air coming in, so it's not 0, it could be 50 degrees or something. So they're very highly efficient heat recovery ventilating systems. And then you try to do more compact shapes. That's kind of helpful. That is tied to if you think about, you enclose a certain amount of floor area, if you have less exterior wall, the building is more efficient. If you have a big rambling building, like it's one floor, you're going to have more surface area from which you're losing heat. So you want relatively compact shapes. So continuous insulation, tight air barrier, good windows, thermal bridge free, heat recovery ventilation, compact shape. Those are the basic concepts for passive house. Passive house, it can be houses, it can be multifamily houses, it can be office buildings, schools. They're looking at hospitals now, prisons, firehouses. It can be, the name is unfortunate, it can be any type of building. So that's and globally, it's like a movement. It's like a serious movement that's going on. So 25 years now, there's the 25th anniversary of that building in Darmstadt this spring. In Darmstadt, Germany, there's an international conference. They're celebrating 20 years of the Passive House Institute and 25 years since the construction of that building in Darmstadt. And I was just at a conference in Vancouver for the North American Passive House Network, and there were like 400 people from North America, but including New Zealand and China, and it's an amazing movement. So now I want to bring it back to here and what's been happening in New York City. There's a group, New York Passive House, and I will just pass these around. This is a little brochure about it. New York Passive House is a functioning organization for 4 or 5 years here in the city. There are 180 professional members, some of whom are, I'm a certified Passive House designer now, and there are a lot of them around who are certified professionals. New York Passive House has been working in New York City, with New York City, to try to promote Passive House within the city. And de Blasio, as we know, issued a fantastic document last fall about this time, his 80 by 50 plan. In that 80 by 50 plan, he actually references, he references Passive House as one of the pathways to reduce our global greenhouse emissions by 80% by 2050. So that was kind of a big boost to the idea of Passive House. And then in January of this year, the Speaker of the New York City Council actually proposed Local Law 701A, which was going to mandate that New York City capital projects be built to Passive House standards. These are properties that are owned by the city. So that came out as a draft in January, and we've been working with the city, specifically the attorneys for the New York City Council who are drafting that legislation, as well as the Mayor's Office for Long-Term Planning and Sustainability, and the Urban Green Council, which gets involved in a lot of the legislation that's written around energy in the city. So there have been a lot of negotiations going back and forth since January. There was a public hearing it was late September, the 25th of September. The proposal as it stands now is that they're referring, the original legislation referred to passive house buildings. They're now calling buildings low energy buildings, and which we support. It's not a branded term, but it's low energy buildings that would be built to passive house or near passive house standards as defined either by the Passive House Institute in Germany or by, there's a Passive House Institute US in this country, which is kind of an offshoot of the German international group. And it also gives the opportunity for the city to actually establish its own kind of group if it wants to set up something like that. But the idea would be that it would be to passive house levels. The other key points is that we would have that all buildings, regardless of whether they were passive house, would be required to reduce their energy use index by 50% from the 2014 benchmarking data that the city's collected on buildings. So you would look at a building type, 2014 benchmarking, and buildings moving forward would have to reduce that energy EUI, is a term, by 50% from that point, no matter what. And 20% of those buildings would be to passive house standards. So these aren't codes yet, they're not building codes, but they're the city trying to lead the way right now and kind of demonstrate. The city's been looking at the work in Brussels. Brussels is I don't know if you lived in Brussels, but Brussels had the distinction of being apparently like the worst energy performing city, like less than 10 years ago. And it is like catapulted into this like major model of how to, behave like as an urban city. So they've passed a law as of January 2015 where all the projects have to be built to passive house. Their definition of passive house standards in Brussels. But part of their system, and we've had people going from New York City's administration going to Brussels to talk to the folks who manage their transformation, and we've had people from Brussels come to the New York Passive House Conference or come to the city and talk to us to kind of talk about how they did that. One thing that you'll probably see is a program where the city may set up like called Leading Edge or some kind of a design competition for projects which will be built to passive house standards. That's coming out of Brussels. So that's kind of the state of New York City's right at the moment. It's an amazing position to be in, and for those of us in the anti-fracking movement, it's like amazing because we couldn't get Christine Quinn and the speaker to do any legislation ever about fracking or anything, and here, like, the speaker of the city council out of nowhere writes a proposal for a law, so it's got serious momentum behind it. Still, not that there aren't hurdles in terms of trying to get it through, but it's such a difference from the efforts we had several years ago with the anti-fracking. Though I have to say, all of that, I think, all is playing into this too. All of that all of these legislators heard at the time we were making all those efforts has had an impact on the people who were there in office now. So that's kind of the city. I'm going to say the city-state. If I miss something, I'll come back to it. And on a federal level, I printed this out the other day from the White House. Has this amazing. This is a fact sheet that's available online. President Obama announces new actions to bring renewable energy and energy efficiency to households across the country. And this is like 10 pages of things all over the country regarding all kinds of initiatives around renewable energy and energy efficiency. It turns out that one of them happens to be related to New York State and what's the Community Preservation Corporation. There's the kind of the cliff note on it is that you would be interested, Sonia, in this about capital solutions to issues facing New York State communities regarding affordable housing. The gist of it is to make to incentivize passive house construction within affordable housing initiatives. It's like a completely excellent thing to do. The idea of reducing energy costs to, within affordable housing. I can pass this around. You can take a look at it. That is so that translated to this. That was August 25th. August 27th, there was a statement. I'll just read part of this. New York State Homes and Community Renewal (HCR) has established a new optional passive house track for applicants seeking competitive points for green building under its August 2015 request for proposals. So this is it's 11 state housing programs. So what they're doing is they're using the idea that if an applicant comes to apply and they want grant money, if they do passive house, they get a bump in their application. Like they get additional points. Like this is occurring in Pennsylvania and in other states also. There's it's a strong movement to just, it incentivizes the integration of passive house into the affordable housing community. Because there are a lot of projects that apply for affordable housing status and money, but they all don't get funded. And they just do it on a point basis. But if you get a few more points, if you do a passive house thing, all of a sudden your project is approved as opposed to disapproved. So that's effectively what, and this is in partnership with NYSERDA, is involved in that as well. Just a couple quick things. These are, and talk about these, but the materials, like when you're creating an air barrier in a structure, this is kind of a technical thing. The materials are very important, like how you control when air moves through the house versus when vapor moves through the house or when rain moves through the house. Like controlling those moisture barriers and air barriers is really critical, and there are some incredibly technical but amazing products that are effectively like Gore-Tex in your house. You know what I mean? Like it breathes, but the rain doesn't get in. So the passive houses end up being very healthy environments because they're not trapping mold or water that's degrading the building. So the structures are designed to be very durable and healthy environments. So these kind of products, they come from Europe, but there's a company in Brooklyn that now stockpiles these products, so you can get them here. This is a great insulation that, we've got a passive house under construction on Long Island now, and we actually designed looking at an occupied multifamily retrofit. This was on West 105th Street. I'm not going to get into the details of it, but that's a very significant challenge, is how do you retrofit occupied buildings? And that, if any of you come across a project where a small, this is like New York City personified here, 10 unit, 15 unit building that's interested in trying to spearhead this effort, like how do you do that? And this was a talk that I gave in Denver a couple years ago about how hypothetically one can do it, and so that's I'm still interested in doing that. So this is an insulation we use a lot. This is called Roxol. This is a Canadian company here. This is spun stone. It's from stone and slag. It's amazing. They actually make it out of that material, but it's fantastic with respect to it's incombustible, great insulation, and it kind of wicks water away. So this is way better than fiberglass bad insulation. It doesn't get in your lungs the same way to have that glass fiber feeling. So this stuff is great stuff. And this is Lunos is one of these heat recovery ventilation systems. This is something which is a unit which you can, in retrofitting a building, you can actually put several of these locally into rooms so that you don't have to run like a machine with ducts and such. So in a retrofit, this company is something that one could consider.
Fascinating.
So that's so open for questions.
I presume since the city is considering it, and you're talking about the federal government, it's cost efficient so that the construction, the cost is reduces using passive house structure.
The construction cost, it at this point in our country, it costs a little bit more. The percentage is kind of debatable, probably on the project, but it's primarily because we don't have products that are the key products are coming from Europe, and we don't have the labor force actually isn't comfortable with it yet. In Europe now, they're building them at the same cost as conventional construction, or even less. It's because it's very simple, but there's only one certified window manufacturer now in the United States, in California, for instance. But there's a great, it's great for kind of incentivizing manufacturers to start making things here in this country. So the issue is that you have to capitalize the project a little bit more, but in the longer term, you're absolutely saving money because you are using less energy. You have less fuel costs and kind of operational costs. So, but there is, it could be 2%, 3%, 5% kind of increase.
So that the long term would offset it
Exactly.
for the consideration of like using it for building a school or hospital or housing or whatever.
Right. No, there's an understanding. You see, the mechanical systems are much smaller. The general offset is you buy more expensive windows and more insulation, but your mechanical system, like we're doing the project I referred to in Long Island, it would typically need a 12-ton heat pump system, and we're putting in like a 3.5-ton system, way smaller because we don't need it. We just need it for supplemental use. We don't need it. So there's a savings in mechanical costs spent on windows and insulation.
Thank you.
Thank you for all the great information. There's two major things that strike me when it comes to Passive House. One is that it's talked about a lot, and I haven't heard that much about it, but it's always referred to in terms of insulation and a lot of cold weather things. It started in Germany. We talked about Canada. How does it relate to warmer weather, especially as climate change is here, and we're getting 70-degree weather at the end of October on a regular basis? It seems like there's going to be many more problems with too much heat rather than too much cold. And then the other thing is with what you said with the concrete, the balconies, right? You called them something else and I can't think of the word, but right. It seems like Passive House has in some cases made it difficult for people to just do something when it's beautiful weather like today, just open your windows. And we now have a lot of buildings where you can't open the window, where you are forced to have either the air conditioning on or the heat on constantly many times of the year in spring and fall when you don't need it at all. And it's very sad that people are sort of being disconnected from the outside. And I know that there's probably a lot of ways you can make Passive House without that, but it seems like there's some amount of that goes on with it. And I'd love to understand that more.
All right, so this was a great question the other evening.
Okay.
I'll answer the first, or a couple of questions. I'll answer the second one first. It's completely possible, okay, no problem to open windows whenever one chooses to in a passive house. This is a common misconception that because it is considered airtight that one doesn't choose to or can't open the windows, but that one can bring fresh air into the structure whenever one chooses to do so. This question about insulating and keeping the heat in the house in the summertime, the insulation around a building will actually help to keep the heat outside the house as well as keep the cooling, any cooling that one's providing in their house inside the house as well. So it's acting to reduce the thermal exchange from inside to outside in that what would be a cooling environment as well as what would be a heating demand environment as well. So, the second question here was a really excellent question. I think it's part of it I can answer. I think the other part, I'd probably suggest other people might be able to answer better. This question about the cooling requirement, the significance of that and importance of that, that's a very, very good question. Passive houses are designed to hold heat in. That's the intention. The name passive, it's working to keep internal heat gains in the house with respect to cold weather. This includes people sitting, I'm sitting here, I have 400 BTUs, I'm generating, refrigerator generates heat, the hot water heaters, lighting, etc. So the building is generating heat. That's passive house wants to keep that heat in the building with respect to cold weather. Now, the issue is that in warm weather climates, that heat is also retained in the building as well. So from a cooling standpoint, it's very important to be shading the building to minimize solar gains during warmer weather. That's a very critical step to minimize the overheating of the structure. The insulation that one provides around a passive house and making it tight will benefit when one does cool the building in the summer. So it'll keep that cool air in as well at that time. But this is an excellent question with respect to warm weather climates. But there are, I told the story that evening that we had a conference, New York Passive House did in June, and there was a fellow from Belgium, and they had worked, the Belgian government, on a couple of different projects. One was a station in Antarctica with respect to a serious cold weather climate, and the other was the design of an embassy which was near the equator somewhere in Africa. And they were both passive house structures. So passive house can be designed to meet a wide range of climate conditions in different climate zones. The last part of this question, which was a really good one, which I don't think I can answer capably, is this question about if we're designing for now, we know that we're going to be dealing with an increasingly warmer climate with respect to climate change. This is happening over time, but it's becoming, unfortunately, more near term now. There was this Council on International Climate Change. We heard a presentation from a woman who's involved in that at the New York Passive House event, and she had said that in 20 years it's going to be difficult for us to be working outside in the summer as regularly as we do now, just because of the change in temperature. And the question that was raised this evening, whether these buildings, if we're designing them a certain way, how will that be modified or adjusted, or will that create problems for us with the climate change which we know will be upon us? That I would prefer to defer to the Passive House Institute, and if I can remember, I'll ask folks there. The Passive House Institute has 50 or 60 scientists who are managing the Passive House protocols, and I would imagine that somewhere there that people are thinking about these types of questions and adjusting or thinking about the standards accordingly. So I hope I've answered this person's questions as at least maybe equal to or possibly a little better than I did the first time I answered them.
Okay, thank you very much.
Oh, I'm sorry. You want?
Yeah, I think the retrofits are really important, and we're really going to need that. And so I'm wondering to what extent it's been possible to do retrofits so far, and what do you see as the biggest challenges there, and how are we going to overcome those?
Great question. Yeah, that is the. All right. So this is another great question from the other evening. Retrofits. Passive House Institute has a protocol for retrofits. It's called Enerfit. It's a slightly relaxed version of the standard for new buildings. Most notably, it has a requirement of 1 air change per hour at 50 Pascal as opposed to 0.6 air changes an hour at 50 Pascal. A good building, just as a point of reference, a good building today that's built in this country might have 3 air changes an hour. So these requirements are much, much more stringent than what's happening in our country today. But the retrofit is slightly relaxed in the passive house world from the new building standard. Retrofits are happening here in the city now, in New York City, and have been for several years. They've generally been happening on a smaller, either single-family brownstone building type or in small multi-family buildings. But there are passive house certified projects that are retrofit projects now in New York City. And this retrofitting has been occurring for many years in Europe as well, and retrofits of various building types. So there's no limit to what can be retrofitted. The most significant challenge with retrofitting, and the most important challenge, I believe, in retrofitting is dealing with occupied multifamily buildings that are to be retrofitted. As I might have stated earlier in 30 years, 80 to 85% of the buildings that we have around us now will still be existing. So we're not going to get anywhere near where we need to be with respect to reducing greenhouse emissions unless we deal with retrofitting existing buildings. Very important. New York City, we obviously have large numbers of rented buildings, multifamily buildings, as well as owner-occupied co-ops or condominiums. These buildings are never vacant, 100% vacant, so that they can be gut rehabbed, which was the most efficient way and easiest way to deal with a retrofit of a project. So the idea of, or trying to understand how one would retrofit an occupied existing building is a challenging task. I am a building architect for several co-op owners corporations. I understand, the general mentality of how an owners corporation worries about its general building or the building systems. Buildings have, 5 or 6 general systems. They've got a roof, exterior walls, the windows, the boilers, electric, plumbing, elevators in some cases. Those are the general systems of the building. Generally co-op buildings or condo buildings, they deal with those systems generally when something is about to break or is in serious need of attention, and they'll spend money on that particular system, usually one system at a time in the building. With respect to this idea of retrofitting an occupied owners corporation or co-op to passive house standards, one strategy would be to develop a master plan for that building with respect to passive house, which understood that if it was to be gut renovated, what would one do to bring it to passive house standards? Then look at all of the systems and look at what kind of work needs to happen near term, middle term, long term in that building. This way one could have a master plan or a roadmap to passive house for that building, but then as systems needed work incrementally, one could do the work on that system as it came up, so that if, for instance, you need to replace windows in the building, you would replace them to Passive House standard windows. Then maybe 2 years later, the roof, or 5 years later, the roof needs to be replaced. You would put a roof down, but put the proper insulation and deal with possible thermal bridges at the parapets and such. But again, working it within a master plan that had been determined in advance that would bring the building to Passive House. This means that the transformation of that building would be over a long period of time. It could be 10 or 15 or 20 years that the building was retrofitted, but at least it would be retrofitted to a strong standard. The hardest piece of this are the individual apartments, where you may need to do work within an individual unit. And I think in that situation, an owner's corporation could say that if a building sold, if a unit within a building sold, that would have to be bought, some minimal work or the work required to meet the Passive House program would be done when the unit was sold. Or if there was a gut renovation that occurred with a present owner, they would have to do the pieces that were related to their unit. So I think that there are ways to do this, but no doubt about it, it's very difficult, kind of ugly, messy process, but one that we have to, sometime soon, begin facing, because a lot of our buildings are in this category. So I think that would be is the most challenging aspect about retrofitting.
My question was, have you heard anything about any legislation in the city that any new construction, private new construction, would have to meet Passive House standards?
Okay, this is another good question here. There is no present legislation that New York City that is on the way mandating Passive House within the private sector. As I've mentioned, there are private sector projects that have occurred already in the city, which are not being driven by any particular subsidies that have been initiated. There's a proposal that's in the works for a 40-unit market rate residential building on the west side of Manhattan. The private sector is beginning to recognize on its own the potential value of Passive House structures. The largest multifamily residential building in the world, the tallest multifamily residential building in the world, is now planned for Roosevelt Island, 28 stories. That is not receiving any subsidies that I'm aware of to drive that project. The city, with its present legislation, is going to work within New York City capital projects to mandate a portion of those projects to Passive House. And I think the city recognizes that it's good from its standpoint that it show how this can be done with its own buildings and its own projects. So to answer that question, there is no legislation underway at the moment for mandating private projects to be to Passive House.
So I'm curious if there are studies on life cycle costing and if they're different between retrofits and new units. And I'm curious if subsidies are big, like this 28-story project. Are there big subsidies involved there, or any subsidies involved? And I'm basically, is it something that depends on goodwill to get rid of fossil fuel, or does it work economically? And I would be for it either way, but I'm just curious.
This Passive House works economically. That's the very short answer here. In Europe, where they've been building the projects for now 25 years or so, Passive House projects are built at a per square foot cost that is basically equal to the standard construction. In our country, the projects are costing 2%, 5% more. I'd say in general, it has an increased cost for window cost, insulation cost. It saves on mechanical systems. The added cost generally is tied to two issues. One is that it is the products, those products, specifically windows, cost more because they're generally manufactured outside of this country. So the market, when the market, our manufacturers get into it and start building windows here in this country, the prices of these projects will drop. So there is not, subsidies are used in other, certainly in other countries, and would be helpful here. The projects do have, because of that little bump, they've got a little higher capitalization cost. The longer term costs, this bump in capital cost is offset over a longer term by lower operating costs with respect to energy, which are quite substantial. I think that the long-term life cycle costs are very good. The buildings are built to be very durable. The focus on the building science of the building with respect to fully understanding where, how the exterior walls are designed with respect to the air barrier, the vapor barrier, and the thermal barriers, and the control of water on the outside of the house. These, when done properly in a passive house, minimize the opportunity for any moisture to be trapped within the exterior wall of the building or coming toward the interior surface of the building, and this prevents mold and water from getting into that system, which obviously limits the durability of the building, and it has an impact on the health of the occupants in the building. So these buildings are designed to be durable, long-term structures with low operating costs with respect to energy. And so I think all of that is good, for them having good life cycle costs. So to my knowledge, the 28-story project on Roosevelt Island does not have any subsidies associated with it. I'm not 100% sure about that, but I'm fairly sure of that. With respect to life cycle studies, I would have to research that or check into the Passive House Institute. They might have some studies with respect to life cycle costs for the projects.
Okay, I'm going to have the last question here. What I wanted to ask is about the White House initiative that you mentioned. Are they by executive order? Is there some kind of subsidies the federal government gives to each state, or how does that work? I mean, how does it translate into actually, real benefit for the people living in this country? So I just want to know.
Well, could someone read it really quickly and see what I think? All right, so this was a great final question from Ling. I do have to say that I remember I was joking at the time that that question was asked, because I passed around, I downloaded from the whitehouse.gov website this initiative that Obama had announced in August, and it was several pages of projects that were cited in this initiative in various states. And I was passing it around the room, and it actually asked if someone could read it a little more carefully, so that they could answer this question. And so I know this question is coming up again here, so I'm looking for that piece of paper. I couldn't find it before this talk, of course. So I can't answer that question any better than I could that evening. What I said though, and what I do believe is that there is money that's associated with it, that money that was going to NYSERDA, and I think that the White House was putting funds into the various initiatives across the country.
Okay, good to know that Obama's doing something by executive order, because I doubt if it will get through the Congress. Anyway, so I just want to say thank you so much, Buck. Thank you.
Really quickly.